This is a webinar on Zend Framework database access. My name is Bill Carwin. I have been working at Zend Technologies for the past year, working on the database access components for the Zend Framework. And I'm giving this webinar today to talk about what you can do with database access. What we're going to cover in this webinar is an overview of the ZendDB component of the Zend framework, and we'll show a lot of code examples of using the class methods, and then I'll talk about using ZendDB in Model View Controller or MVC web applications. The first thing that you come across in ZendDB are the adapters. These are classes that you use to connect to a variety of different relational database brands, including those listed here, that support the PDO and native extensions in PHP. You do need to have those extensions enabled in your PHP environment, but ZendDB provides a consistent and common interface that allows you to program with one API to multiple database backends. The ZendDB component also includes basic CRUD functions for creating, reading, updating, and deleting database rows. We'll cover those a little bit, and I'll show you some examples. There are some convenience functions in ZendDB that allow you to interpolate PHP variables and expressions into your SQL strings safely without undue risk of SQL injection issues. There's a query profiler component that allows you to measure the duration of your queries and get reports back so that you can use this during debugging and development to find the bottlenecks in your application. ZendDB Select is a procedural interface so that you can write code to build up a select query out of application logic. I'll show some examples of that too. And finally, there is an object-oriented solution for abstracting table and row access to your database. This is similar to the active record pattern that is popular in other frameworks, but basically it's an object-oriented interface to accessing data. First, let's talk in more detail about database adapters. First thing to know about is how to connect to a database. The factory method of the ZendDB class allows you to do this. You can specify the brand of database to which you're connecting. Really, this is the class name of the adapter that is going to be used, and then subsequently a series of parameters that you use to specify the connection. Mostly these parameters are the same from one database to another, but there may be certain parameters that are specific to a given brand of database. In this example, I'm connecting using the MySQLi PHP extension and specifying the host, which is optional if it's localhost, that's the default, the database name, and then a user and password credentials with which to connect. Alternatively, you can specify the connection parameters using a Zend config object. This is another component of the Zend framework with which you can read a config file in which your connection parameters are stored, and then use that as the argument to the ZendDB factory method. This makes it convenient to store your connection parameters in a way that you can edit easily outside of your code, or have a different config file on your testing server as you do on your production server. The ZendDB factory method automatically knows when it's being passed an object of the Zend config class and does the appropriate thing to interpret the parameters. Note in this example that the parameters are shown in my example config.ini, and you have to match the names of the config properties in order for it to understand how to decompose it. All right, the very easiest way to execute an SQL query and get results back is with the fetch all method of the database object. Remember, the database object is the one returned by that factory method we saw on the previous slide. So the method is called fetch all, and you just pass it an SQL statement as a string. What you get back is an array of associative arrays, the outer array being the rows and the associative array mapping column names to the values that were returned in that result set. It's a very easy and straightforward way of using PHP array data structures to represent a result set from a database. Instead of fetch all, there are also methods for fetching individual rows, so you can loop through it in case you need to do additional steps, or if you want to cancel out of the loop halfway through. And you can also fetch rows as other structures, for example, indexed by an integer, the column position, rather than by the string column name. Or you can fetch back as an object. Users of PDO may recognize some of the conventions being used in this. The ZendDB interface was modeled after PDO, but it also extends to non-PDO PHP database extensions to make it all consistent. If you need to execute a query multiple times, for example with different parameter values, you can prepare it using the prepare method or the query method, and then subsequently execute it multiple times. In this example on this slide, notice that there's a parameter placeholder for the bug status value. At execute time, when I execute the statement, I supply an array of parameter values that are substituted for the one or more question mark placeholders that are in that SQL statement. Then subsequently fetch all the results based on the execution of that statement. I can also execute the same statement object a second time, or a third time, or multiple times, using different values, and they get substituted in for the parameter placeholder. Note that when using parameter placeholders, we're really not substituting the value into the string form of the SQL statement. We're passing the parameter values to the RDBMS server, where it is combined with a machine-readable compiled form of the query. So at no time do these values actually get combined with the text format of the SQL statement. This is important for reducing your exposure to SQL injection issues. I'll talk about that in a moment. Inserting data, that is creating new rows in the database. There's an insert method for the database adapter object, and when you pass the name of the table and an associative array mapping columns to values, these are supplied to an SQL insert statement as parameter placeholders and then subsequently executed. So by calling this method right away, the new row is created in the database. If your table has an auto-generated primary key, you can get that value back with the last insert ID function. I'm getting a comment that the sound is a little bit low, so I'm going to try to speak up a little bit. When updating data or changing existing rows in the database, you can use the update method. This is very similar to the insert method, but you just have to add in a third parameter, which is the condition for rows to change. The return value of this method is the number of rows affected by the update, which may be 0 if your condition matches no rows in the database. And finally, the delete method is very similar to the update method, except you pass no column value pairs. You just tell it which table and the condition for the where clause, and it takes care of it. Also returns the number of rows affected. Another method that's very useful is to get a description of the metadata for a given table. In this case, where I'm asking for the metadata about the bugs table, and it returns as a PHP array mapping column names to a subordinate array that has a number of properties for each of these columns. I'll show you that on the next slide. But this is a way you can have your application discover what are the columns and properties of those columns of your table at runtime. Here's the explosion of that single bug ID, the first entry in that array we saw on the previous slide. And you see that there are a number of